let us try to revise some of the concepts that we have already studied. Valencies, writing formulae, and how to balance a chemical equation. Let's take some examples. If we are given a chemical equation in this form, that is, we are given the names, potassium bicarbonate reacts with sulfuric acid to give potassium sulfate, carbon dioxide, and water. We have to balance this equation. So first of all, we have to write the formulae of all these species. So we start with potassium bicarbonate. Let's try to write the formula of potassium bicarbonate. So we have potassium bicarbonate. The first step is to write the symbols of the elements and radicals. So the symbol of potassium is K, symbol of bicarbonate is HCO3. So we write the two next to each other. Now we check their valencies. The valency of potassium is +1. The valency of bicarbonate is -1. So when a number is not written, that means 1. So valency of bicarbonate is -1. So the valency of potassium is +1, valency of bicarbonate -1. So we write the valencies. Now we interchange the valencies. So we write the two. We ignore the signs. This was plus, we ignore the plus sign. We ignore the minus sign. And then we interchange. So this 1 becomes a subscript here. And this superscript 1 becomes a subscript here. We know when we have a radical, we enclose it within brackets. But since this is 1, which can be neglected, so even if we write HCO3, it's right. Had we received 2 or 3 atoms over here, then this becomes a problem and we have to enclose it within the brackets, because that 2 or 3 can be with any number. That is when we have to enclose it within brackets. Since we do not write 1, it can be neglected, so we can write it within brackets, or it can be simply written without brackets. So the chemical formula becomes KHCO3. The HCF of 1 and 1 is 1. So on dividing both by 1, we get 1, which can be ignored. So the chemical formula of potassium bicarbonate is KHCO3. So we got the formula for this, KHCO3. We know sulfuric acid is a trivial name and we remember its formula, which is H2SO4. It's an acid generally used in laboratory and we know its formula is H2SO4. We have to now find the formula of potassium sulfate. Let's try. We write the symbols for both. Symbol of potassium is K, symbol of sulfate is SO4. So we write the two. Now we check the valencies. The valency of potassium is +1. Valency of sulfate is -2. So now we write the valencies. Valency of potassium +1, sulfate -2. In the third step, we interchange the valencies. So we have K +1, SO4, 2. We ignore the signs, the positive and negative signs, and we interchange the valencies. So the superscript here becomes the subscript, and the superscript here becomes the subscript. Since we get 1 here, we can ignore the 1 and we can simply write the radical without using the brackets. So we get K2 SO4. The HCF of 2 and the 1, if we write here, So the HCF of 2 and 1 is 1. So when we divide 2 by 1, we get 2. When we divide 1 by 1, we get 1. So the formula of potassium sulfate becomes K2SO4. Now let's read the equation again. We found out the formula of potassium bicarbonate, which is KHCO3. We found out the chemical formula of potassium sulfate, which is K2SO4. And the remaining formulae we know. We know sulfuric acid is H2SO4. Carbon dioxide is CO2. And water is H2O. So now let's write a chemical equation. We have KHCO3, that is potassium bicarbonate, reacts with sulfuric acid to give K2SO4, that is potassium sulfate, plus carbon dioxide plus water. Now we have to balance this chemical equation. So the first step is we write the different atoms which are present. We have potassium, hydrogen, carbon, oxygen, hydrogen we have written, and sulfur. Oxygen also we have written. So these are the different atoms present. Now let's count the number of atoms on the reactant and the product side. Potassium we have 1, hydrogen we have 1, plus 2, 3. Carbon we have 1, oxygen is 3, plus 4, 7, and sulfur 1. Similarly on the product side, we have 2 potassium, we have 2 hydrogen, we have 1 carbon, oxygen we have 4, plus 2, 6, plus 1, 7, and sulfur we have 1 atom. So these are the different number of atoms present on the reactant and the product side. Let's rewrite our chemical equation. So now we see 1 atom of potassium on the reactant side, 2 on the product side. So to balance potassium, we have to make this 2. How do we do that? We make this 2 molecules of potassium bicarbonate. So when we make this 2, we get 2 atoms of potassium. We get 2 plus 2, 4 atoms of hydrogen. We get 2 atoms of carbon, 3 to the 6 plus 4, 10 atoms of hydrogen, 10 atoms of oxygen, and 1 atom of sulfur. We have made no change on the product side, so this remains the same. Now if we look at the equation, potassium is balanced, hydrogen is not balanced. We have 4 atoms on the reactant side, 2 on the product side. So to balance hydrogen, we have to make this 2. That is, we have to take 2 molecules of water. When we take 2 molecules of water, this remains the same. Potassium remains the same. Then we have hydrogen. This becomes 2 to the 4. Carbon remains 1. Oxygen becomes 4 plus 2, 6 plus 2, 8. And sulfur remains 1. We have made no change on the reactant side, so this remains the same. Now let's look at the equation. So potassium is balanced, hydrogen is balanced, but carbon is not balanced. On the reactant side we have 2 atoms, on the product side we have 1 atom. So to balance carbon, we have to make this 2. This is possible only if we take 2 molecules of carbon dioxide. When we make this 2, we get 2 atoms of potassium. We get 4 atoms of hydrogen, 2 atoms of carbon, 4 plus 4, 8 plus 2, 10 atoms of oxygen, and 1 atom of sulfur. We have made no change on the reactant side, so they remain the same. Now let's look at our equation. Potassium atoms are balanced, hydrogen atoms are balanced, carbon atoms balanced, oxygen balanced, and sulfur balanced. So from the names given, we formed the chemical equation, writing the chemical formulae and hence by using these techniques, that is by using the hit and try method, we balanced our given chemical equation. Let's take another equation now. We have manganese 4 oxide reacts with hydrochloric acid to give manganese 2 chloride plus water plus chlorine. So first of all, we need to know the chemical formulae. So let's start with manganese 4 oxide. So these are the symbols. So symbol of manganese is Mn, symbol of oxygen is O. So we write these symbols next to each other. Now let's check the valencies. We know when an element exhibits variable valency, the valency is written using the Roman letters. So this 4 inside the bracket shows that manganese exhibits variable valency, and in this compound it has the valency plus 4. And for oxygen, oxide, when we form a compound, we replace the name, we use the suffix "ide". So this shows that the non-metal used here is oxygen. The valency of oxygen is -2. So we have the valency of manganese as +4. And valency of oxygen, which is the non-metal here, its valency is -2. Now let's interchange the valencies. We ignore the signs. The superscript becomes the subscript. The superscript becomes the subscript. Now in this case, the two subscripts are 2 and 4. Their HCF is 2. So when we divide this 2 by 2, we get 1. When we divide this 4 by 2, we get 2. So this is the chemical formula of manganese 4 oxide. Now let's look at our equation. We got the chemical formula of this species, which is MnO2. Now we know hydrochloric acid is HCl. We need to find the chemical formula for manganese 2 chloride now. So let's write that. Let's write the metal and the non-metal in this case. So the metal is manganese, its symbol is Mn. Chlorine, its symbol is Cl. Now we check for the valencies. So manganese chloride. We know where manganese in this case is showing variable valency. The valency is shown by the Roman letters. So in this compound, manganese shows +2 valency. And chloride, we know the non-metal in this case is chlorine. So the valency for chlorine is -1. While writing the names, we use the suffix "ide". So in this case, the non-metal is chlorine having valency -1. So let's write their valencies. The valency of manganese is +2. And the valency of chlorine is -1. Now let's interchange the valencies. We have Cl1. So when we interchange this, the superscript becomes the subscript. And in this case, we get 2 here. The HCF is 1. So on dividing both by 1, we get the same numbers. So the formula of manganese 2 chloride is MnCl2. Now let's look at our equation. So we have found out the chemical formula of manganese 4 oxide, which is MnO2. Hydrochloric acid is HCl. We found out the formula for manganese 2 chloride, which is MnCl2. Water is H2O. And chlorine is Cl2. Since chlorine gas exists in the diatomic form, Cl cannot exist independently. So chlorine exists as Cl2. So let's write our chemical equation. This is the chemical equation that we get. MnO2 reacts with HCl to give MnCl2 plus water plus chlorine. So what are the different atoms that we have? We have Mn, O, H and Cl. Now let's count the number of atoms present on both the sides. Mn we have 1 atom, oxygen we have 2 atoms, hydrogen 1 and chlorine 1 atom. Let's look at the product side now. Starting with manganese we have 1 atom, oxygen we have 1 atom, hydrogen we have 2 into 1 2 atoms and chlorine we have 2 plus 2 4 atoms. Let's write the chemical equation. So if we see now, the manganese atoms are balanced. Oxygen on the reactant side we have 2 atoms, on the product side we have 1 atom. So now we have to balance oxygen atoms. So in order to make this 2, we have to take 2 molecules of water. So now if we count the number of atoms, we have made no change on the reactant side. So this remains the same. And on this side we have 1 atom of manganese. We have 2 into 1 2 atoms of oxygen. We have 2 to the 4 atoms of hydrogen and 2 plus 2 4 atoms of chlorine. Now manganese is balanced, oxygen is balanced, hydrogen on the reactant side we have 1 atom, on the product side we have 4 atoms. So let's balance hydrogen. In order to make this 4, we have to take 4 molecules of HCl. So when we make this 4, we get this number remains the same. Then we have oxygen which remains 2, hydrogen becomes 4 and chlorine becomes 4. We have not made any change on the product side. So this remains the same. Now if we look at the equation, our manganese atoms are balanced, oxygen is balanced, hydrogen is balanced and chlorine is balanced. So this is the balanced chemical equation. So we have seen for all languages the basic structure remains the same. The alphabets combine to give words, the words combine to give sentences, and these sentences follow certain set of rules, that is the grammatical rules. Similarly, for the language of chemistry, we see that the chemical symbols combine to give the chemical formulae, the chemical formulae combine to give the chemical equations, and these chemical equations also follow a set of rules, the rules of balancing. So the chemical equations follow the rules, that is they have to be balanced. So we get the balanced chemical equations.